Hi, very good morning to you. It's Gene from maverickstar. I'm trying to get an idea and an angle on it as to why the magnetic North Pole for the last nearly 3 months now has just been caught up in a particular area and came to virtually, a grinding halt just as we'd surpassed, the 40-degree mark. And, just trying to work out why that is, and if we can learn something more about what is actually going on. We can just find the position. Hold on. We've lost the magnetic North Pole, guys. There we are. Let's bring that into view. So yeah, you can see we've just passed the North Mid-Atlantic Ridge, which is an active volcanic region on our planet. This ridge runs all the way down to the Mid-Atlantic and the South Atlantic. A huge volcanic crack, if you like, in the tectonics of our Earth. And we just passed it this year. We crossed over that trench, and now the pole has come to a grinding halt. So I'm just trying to understand what's going on beneath the surface of where that region is. We know that it's got to be a component of what is taking place over in Canada with the magnetic intensity weakening, and what is taking place in Russia, because those are the two main intensities over the northern hemisphere. And our dipole, our magnetic North Pole, is a product of those two intensities. It's not actually something that is physically there, other than it is positioned because of its being caught up in those two intensities. If one was further weakened, if Canada went much weaker, the intensity in that region, and dropped from, say, 55,000 nanoteslas to 30, we would see the dipole move further west. So it's a component then, I guess, of what's going on in Canada and what is taking place in Russia. And likewise, if Russia's intensity was to increase over 60,000 nanotesla, we would see the pole move west again because of that. I was looking at the jet stream patterns on North Score. Let's go over there and have a quick look at that. Oh, before I do, I did start running a few theoretical theories on this. That if our core that generates the magnetosphere and the dipoles, what we're calling the magneto inside our core, is a product of something that is rotating, and that sets up an electrical dynamo effect, which in turn gives us our dipoles, the north and south poles, then could we be, as we're not seeing it move in this region, could we be over a vicinity of vortex, something like the centre of a rotating body of that material that generates the dynamo? Could we be at the centre of that? Like when you're watching the water go down your sink, it creates the vortex in the centre. If you drop something into that sink at that point in time, at the edge of the sink, not directly over the plug hole, it would make its orbit around that vortex, and then slowly get focused in on the tightening of the vortex, and would be trapped up in there. I was trying to think, maybe, are we witnessing something of that kind? And, does the North Atlantic Ridge have something to do with this? Or is it just a simple component of the poles are neither being tugged one way or another by the larger intensities over Canada and Russia? Very, very questionable as to why it suddenly stopped. We saw this, remember, back in February, where it came to a halt, retreated easterly a little bit, and then slightly, when it started to pick up momentum and move westerly again, it did it at a very, very slow but noticeable increase in speed over distance. This time it seems to have hung around a little bit longer than what it did back in February. So we really are in new territory with this. We don't know why it is behaving like this, but this is more now a time to study this than ever before. I think you would agree that when you start to see any activity, even if it's no activity, after a prolonged period of migrational time, and then we start to see it stop, we have to ask the question, are we getting closer to something on a greater magnitude? I know, reading the comments section, people are questioning whether there is like a tension building up, and at some point that tension will release, resulting in a rapid migration, as the experiments that we've conducted shows that when you get to a certain point of around 40 degrees of migration, all of a sudden the weaker field lines are left, which enable a slower migration, and we go into them stronger field lines. One way or the other. Anyhow, it's very early in the morning, but we cross that boundary where we enter the different force of field lines, and therefore we get the acceleration like we see in that experiment that we've conducted. So it's very interesting time that we're in. And it is on that note, I want to mention just something. We had around 4,000 people view the video that we did on the latest position of the magnetic North Pole yesterday. And this was the first time I've ever witnessed this, that not one person chipped in a few bucks on PayPal. This is also new territory for us here, because it's like every day, it's just like your lives, guys. You don't put fuel in the car, all of a sudden the car stops on the road. This observatory is run at the most efficient possible way we can do it. But when the funding stops, it's like everything else in life, it comes to an end. So, I keep trying to explain to people, that it wouldn't take a lot if, a few more people was to support what we do here. This is a bespoke observatory. It's got bespoke equipment. You ain't getting the same service anywhere else. No other YouTuber have their own equipment like we've got, and certainly there isn't a dedicated website that covers not just the magnetic poles, guys. Have a look over our website, what we cover. We cover a lot. You've got solar activity, Arctic ice activity. You've even got Schumann resonance information on there, as well as volcanoes, and you can type in what latest magnitude of earthquake you're interested in knowing, what happened in the last 24 hours. And that site is dedicated to all those things for you guys. You can also look at the historical trimag data and magnetosphere data and magnetometer data from other parts around the world. And of course, then we have something even more unique, and that is the Earth Health at a glance, where we look at CO2 collected by our own CO2 atmospheric monitoring equipment, oxygen likewise, background radiation, and it goes on and on and on. And that is a compiled amount of data which would ordinarily be worth, more than just a coffee. But sometimes, sadly, it's a struggle to get a coffee for that information. Where else can you get a trusted source that gives you all this information in this day and age? On another go, let's go over to North School so we can just have a quick look at the jet streams before we go on. So we're over at North School, we're looking at the jet streams, and you'll note where England is, the United Kingdom. We're at a latitude of 50 degrees there, and the jet stream, which should be at 60 degrees, which is the polar jet stream, is right over England right now. And if you go further south, you'll see that the jet stream that should be at 30 is almost at 20 degrees. It's like the jet streams have moved their position by around 10 degrees latitude, and as a result, we do see some fragmentation. You can see that over the States at the moment, there is a polar jet stream reaching straight down into the subtropics, and when you get cold air mixing with that warm humid air, the chances of precipitation increase much more. And it's the same case, I've got to say though, I will say, this is probably the best I've seen the jet streams look for a while on our planet. There is almost two distinctive jet streams, which is what we should have. One over 60 degrees north though, and one over 30 degrees north, and likewise over the southern hemisphere. So they're not looking too bad, and they're certainly not as big as what we have witnessed in the past. And things are changing over the northern hemisphere. We are slowly creeping back into those winter months, and if we pull up the temperature on surface, we can start to see those darkening purple regions reform back over the northern hemisphere. Now, I've pointed this out before. This pattern over the northern hemisphere fits very closely with the magnetic intensity map, which means that where the coldest regions are on our planet are usually where the highest intensity is, although we are not there in those winter months where the trend comes out a lot more. So if I am right about temperature and high intensity of magnetism being related to each other, then it's a very delicate it means that it's not going to show the trend all the time, but when it crosses a certain level, then it does. It certainly is the case for over the southern hemisphere. We know that where the strongest magnetic intensity is if we put the intensity chart on there, it would be creeping up over the south coast of Australia, and that's why we see a very strong dark purple, and obviously that represents sub-zero temperatures over the Antarctic. So that fits. And if we look to more the left hand side, we know that there's a weaker plumage of intensity there, so it fits seasonally, but it does only show the trend at a specific point in time. We're going to come back in a couple of months and I'm going to show you, as I have done before, the magnetic intensity chart over the northern hemisphere and then the temperature chart. The other thing I was looking at, which I'm going to quickly pull up, you can have a look on our website at this, under the solar information, you can have a look at the aurora and its current position, because this is also a component of the dynamo in our core of our Earth, which is setting up the product for that anomaly that we enjoy as the aurora over the northern and southern hemispheres. So just having a quick look at the aurora and its current position. I've put that red circle in the centre of that because you would normally think that that's where the magnetic North Pole is, and if that was the case, it'd put it back almost originally where it started to migrate 100 years ago. But what you have to put into this consideration is that the Earth rotates, and so does that change. That slightly epicenter of where that circle has been put in there by me, and that plumage that you see, the green plumage, also moves around the world. So I suppose you get a good idea of where, if we didn't have the equipment, where the magnetic North Pole was by just watching perhaps a week's worth of aurora movement, and we could probably predict that somewhere in the centre of that would be a rough idea of where the magnetic North Pole was. But as the Earth rotates, so does that plumage, and that slightly elliptical circle in the centre move as well over different territory, and that's why sometimes we get auroras over Canada, sometimes we get auroras over North Denmark and places like that. So you can't really, just looking at a photo of this, pinpoint the magnetic pole and its current position, but it does give us a sort of rough idea as to where it is. And of course, you wouldn't expect anything else other than it to be, around the rotational axis of our planet or thereabouts.